Finding the gradient vector.
Gradient is. In vector calculus, the gradient of a scalar field is a vector field which points in the direction of the greatest rate of change of the scalar field, and whose magnitude is the greatest rate of change. The maximum rate of increase occurs in the direction of the gradient.
In the real world, the gradient can be used to show the change in temperature, time, or distance. It can also be used in graphic design.
The notation for the gradient is, for f of x, y, the gradient xy is equal to partial derivative with respect to x, I, plus partial derivative with respect to y, j. For a function x, y, z, the gradient f of x, y, z is equal to partial derivative with respect to x, I, plus partial derivative with respect to y, j, plus partial derivative with respect to z, k.
For an example of this, let the function of x and y equal x squared y. To find the gradient of the function, first find the partial with respect to x, which is 2xy. Then find the partial with respect to y, which is x squared. Therefore, the gradient of the function is 2xyi plus x squared j.
For part B of this example, find the gradient of the function at the point 3, 2 for the same function x squared y. First, take the same partials of x and y where x equals 2xy and y equals x squared. Then plug the point 3, 2 into the partials so that x equals 12 and y equals 9. Therefore, the gradient of the function at the point 3, 2 is equal to 12i plus 9j. Thus, this concludes finding the gradient of a vector function.